Hi everybody, in this video we're going to review the models of the atom, and we'll also start talking a little bit about what happens when you change the number of the subatomic particle. Remember that we started out with Dalton's model of the atom, where you have this solid atom where he thought that was as small as you can get and it can't be broken apart. Then Thomson came along and discovered the electron, and he thought that the electrons in this positive substance were evenly distributed. Remember, he used that cathode ray tube to shoot this beam of electricity down the tube and figured out that that beam of electricity is made up of electrons, which have a negative charge. And he embedded those electrons in a positive sphere. And then Rutherford came along. He worked under Thomson initially and started out with this model of the atom, but then did the gold foil experiment and shot those alpha particles at the gold foil, figured out that most of the alpha particles went straight through, and that told him that the atom is mostly empty space. But he also saw that occasionally those alpha particles would get deflected by the nucleus and they'd be shot off at an angle. Remember, the alpha particles are positive, and when they come close to that positive nucleus, they get shot off at an angle. So he discovered that there's a nucleus with protons in it. And then a little bit later, Chadwick figured out that there are also neutrons in it too. And then in that space around the nucleus, you have a lot of empty space with these teeny tiny little negative electrons. Oops, too far. All right, so to overview here, we've got a nucleus that has a positive particle, and this neutron in it too has a positive proton, and the neutrons don't have any charge, they're neutral. We've got electron orbitals. The electrons are not inside the nucleus, instead they're around it. They're outside. And that space where the electrons are is mostly empty. Those electrons don't take up very much space. They have very little mass. They have a lot of charge, remember, but they have very little mass. Protons have a positive charge, and they're in the nucleus, and they are responsible for a lot of that mass in the nucleus. The rest of the mass is the neutrons. Neutrons don't have any charge. And then electrons are negatively charged and have very, 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 very little mass. So we'll essentially say they don't have any mass. So what happens if we change the proton? Here we've got an atom with one proton and one neutron and one electron. That proton, or that atom, is the element with atomic number 1 because it has one proton. That atomic number is determined by the number of protons. That element's name is hydrogen. So what happens if we have two protons? So now we got two protons. You also see that you have two electrons, but you still just have one neutron. But since we've changed the number of protons, we changed the atomic number and we changed the element. So now this atom is a helium atom. So the rule is if you change the atomic number, you change the number of protons. Protons and atomic number are the same. So if you look at the periodic table, which I'll show you in a little bit, and you find the atomic number, that's also the number of protons. And if you change the number of protons, that means you have a different atomic number, and so you're looking at a different element. What happens if you change the neutron? The neutron's represented by this blue sphere here. So here in both of these atoms, we have one proton. We have one electron, but this one has one neutron and this one has two neutrons. So we didn't change the atomic number. Since the atomic number is still 1, it's still hydrogen, but now we've changed the mass. This one has a mass of 2. Remember, I told you before we were going to round those masses to 1 and say that a proton has a mass of 1 and a neutron has a mass of 1. So this is a mass of 2. And this atom has an atomic mass of 3. This is called an isotope. We'll get into more on this later, but an isotope is the same element, but it has a different mass because it has a different number of neutrons. So if you change the number of neutrons, you change the mass. As long as you don't change the atomic number, then you haven't changed the type of element. If you just change the neutrons without changing the protons, you change the mass. And in doing that, you make an isotope. To find the atomic mass, you'll take the number of protons plus the number of neutrons. Sometimes you'll see the element symbol written like this. So here's helium. They'll put the atomic number down here. So here you have an atomic number of 2. That number won't change as long as this is helium. Helium always has an atomic number of 2. But helium can make different isotopes. So this is helium with an atomic mass of 4, meaning it's got those 2 protons, and it also has 2 neutrons. So to get this atomic mass, you do protons plus neutrons. So here I've got carbon. Carbon is always 6. If you look at the periodic table, its atomic number is always 6, protons in a carbon atom. So same atomic number. But carbon can make 4 different isotopes. So here, if you subtract, if you do 6 minus 11, you'll get 5. So this carbon atom has 6 protons and 5 neutrons to get 11 for the mass number. This one has 6 protons again and also 6 neutrons. So you have carbon 12, mass number of 12. This one is 7 neutrons to get 13, and this one's 8. So you get carbon 14. And we'll come back to the atomic mass calculation in a little bit.